Okay, so yeah, hope you all can see my slide. So welcome to Multimodal Weekly. This is a virtual webinar series hosted by the team at TwelveLabs. For those of you who are new, we an startup focused on building multimodal video understanding technology. This is an initiative that we've been running over the past 2.5 years or so, meeting on a weekly basis to discuss highly relevant technical topics in the domain of video understanding and multimodal AI, right? So we have researchers from academia coming and talk about the latest work and papers in multimodal AI foundation models. We have founders and partners coming and share different like application of multimodal in a variety of verticals. We have a lot of community developers and members who've been using our API technologies coming and talk about the projects that we've been building with TwelveLabs. And occasionally we have internal speak as well, internal speakers as well, like internal engineers and solution engineers and research scientists, for example, talking about like the technicalities behind our video understanding platform. So here, this is some example speaker profile that we got over the past month or so. We have a variety of developers building advertising application on top of TwelveLabs, um, social media application as well. Last week we have a research talk on like video generic models and improving reasoning capabilities of that one, and then another developers who like been building a local first video indexing open source application, which is pretty exciting. So for today's session, we have two presentations. Both are very exciting. So the first one is going to be a research talk from Woongyeong and Kangsan Kim. They both currently student at KAIST University in Korea, and they will present their work called WorldMM, which is a novel multimodal memory agent that can construct and retrieve from multiple complementary memories, encompassing both textual and visual representation. So this is personally super exciting for me because yeah, video vision and video reasoning is a important topic for TwelveLab as well. So could be so curious to hear from the academic perspective on techniques, experiment, and evaluation, all the learning that you've done to build a highly capable memory agent, specifically for video reasoning. And then the second half of the session will have Prashant Trivedy, who's calling all the way from New Zealand. He will present an application that he's been building on top of TwelveLabs API. It's called GameCut. This is an AI-powered video highlights for sport creators to turn raw footage into viral content in seconds. So um, sport sport understanding, sport highlight generation is actually a very popular use cases for TwelveLabs. Given that our model has been specifically trained on a lot of sport content. So yeah, super curious to see how Prasan has been able to demonstrate the capabilities of our technology and build an application that have potential like viable commercial you know use cases, right, for real world sport organization. So yeah, these are the agenda that we have today. And just quick note on the logistic for the attendees, feel free to send your question on the Zoom chat, and then I will surface them to speakers. And then after each session, we'll have a short 3 to 5 minutes Q&A, so that you can unmute and ask your question live as well. So with that, I will stop sharing my screen, and then I will let the first group of speaker to unmute and start presenting.
Okay, thank you, James, for the introduction. And may I share my screen?
Yeah, you should be able to.
Yep. Can you see the screen? So
Yes, you can see it.
yes. Okay, let me begin. So hello, I am Woongyeong from KAIST, and we really appreciate the opportunity to provide some introduction of our recent research. And today we'll present, as James introduced, we'll present our recent work, WorldMM, Dynamic Multimodal Memory Agent for Long Video Reasoning. And we hope this webinar can be very interesting to you guys. And before we begin, let us introduce ourselves. I'm Woongyeong and a master's student at KAIST, and my current research interest is multimodal LLMs and agentic AI. And the next presenter, Kangsan Kim, is PhD student at KAIST, and he was previously visiting student at NYU last year. And his research interest is also on agents and multimodal LLMs. So for the main texts, these days, like concept of long videos has shifted from like previous few minutes long video to hour-long video with like representative benchmarks such as LB bench or video MME long that are often used for technical reports of like big tech companies. And most current video LLMs handle long videos by passing like sampled or selected frames to the model, which is limited by the model's context limit. The text in the like box is the excerpt from the Quant3VL technical report, and it says like it samples for the video by 2 frames per second, but it caps at 2048 frames per video. And this is actually very like small number of frames. And recent SOTA video LLMs such as like GPT or Gemini can also process an hour of video when they sample with 1 FPS. For example, like Gemini 3 Pro has a context limit of 1 million tokens, but when it's divided by the like number of tokens consumed by each frame, it can only process like 3,800 frames, which is like 1 FPS for 1 hour video. So we know that it's very like short like length of video for usual like understanding. So like scaling to day-long video, and with the recent rise of physical AI, including like AI glasses and household robots, scaling video understanding to day-long or even beyond has become very increasingly important. Imagine you wear an AI glass, and we usually expect them to serve as like a personal assistant where it can remember what you ate last like for dinner and so on. And as it is very like rising topic, Eagle Life has presented a wonderful benchmark towards this direction, and it includes like week-long egocentric videos collected from 6 participants. And this is like one of the major benchmarks for our work. And as pre-processing every frame and feeding them to video LLMs is very impractical and is often ineffective due to excessive context, and is like every frame can be like noise when like small number of frame is relevant. And recent approaches focus on converting like pre-processing videos into textual representations. Textual representation like includes something like caption and even beyond something like graph structure. Yet there are some key questions remaining. First one is, can visual details be fully represented via text? One very typical scenario, as you can see from the second case in the figure, is to retrieve text from the preprocessed caption. However, visual details like color in this example cannot be fully encoded into textual representations. And here, like while M3 agent here utilizes non-textual data by like preprocessing the like excessive preprocessing to like identify the personal via like speech or like face detection, is limited to like pre-processing step and is not fed to the inference stage. Then you might say like, isn't it good if we retrieve both text and visuals along together? However, like visual details are not always required, and we found that excessive visual tokens rather distract the video LLMs to locate relevant evidence from the given huge amount of context. And to this end, to fully exploit multimodal information, rather than relying only on text or exhaustive like input contexts, including both textual or visual representations, like we propose to leverage multiple types of memories here, consisting of both textual and visual representations, along with the adaptive memory retrieval to better handle multiple memory. And below is the concept figure comparing ours to existing works shown before. Instead of relying just on textual memory, or like retrieving both text and like interleaved image or video frame, we built multiple memories, including episodic, semantic, and visual memories to like build like complementary memories. And our retrieval agent iteratively search for the required memory, like retrieving factual memory first in the example, and then look for the like visual detail at visual memory at the next step. So this is like very high level our motivation, and let us introduce like overview of our framework. And here is the overview of our proposed multimodal memory agent called WorldMM. It is a dynamic multimodal memory agent that builds separate multimodal memory at multiple modalities and granularities, and iteratively selects the most relevant memory. The total process can be split into largely three parts: multimodal memory construction at first, and adaptive memory retrieval, and response generation at the end. And I will introduce each component at the following slides. So one of the major memory here is episodic memory, which encodes events at the video into knowledge graphs via the video captions. While video caption itself can be helpful by retrieving the relevant one by like very famous text embedding models, to effectively encode factual events across long time spans and to maintain like consistency between each like same entities, we extract factual triplets to generate knowledge graph. However, we found out that like relying on a single fixed temporal scale is impractical. Like for example, consider the two different queries, like where did I leave my class? This can be answered via just simply looking at short segments of the video. Maybe typically just under a minute of video is like sufficient. However, the next query, what happened in the second half of the soccer match, can fully answer by watching full like second half of like 45 minutes of video. Therefore, for the episodic memory, we believe that maintaining multi-scale memory that encodes events at different temporal granularity is important. Therefore, like while our finest caption is generated for every 30 seconds, we also maintain other time granularities like 5 minutes or 1 hour to like build multiple timescale memories for episodic events. And the second memory is semantic memory, while episodic memory is like widely used textual representation of the video. It stores events at individual timestamps. And usually most recent current systems do not consider capturing long-term and evolving knowledge over the time. So we consider storing another textual memory called semantic memory that encodes such a long-term evolving knowledge like relationship or habits that may evolve over time. While we also generate a knowledge graph at the episodic memory, we also build the semantic memory with the knowledge graph in terms of the knowledge graph. But here we use a more sparse time span, like compared to like 30 seconds of the finest like granularity of the episodic memory. We use more like larger timestamps. So for example, like 10 minutes to encode long-term knowledge and extract semantic triplets other than factual triplets. Like factual triplets, like sometimes usually encode like factual events, but semantic memory encode something like in the green box, I wears glass, something like this, like very long-term high-level memories. And also, we introduce a consolidation process to continuously update and compress the knowledge. While we collect knowledge continuously and like store like a vector or like build a knowledge graph, if we reach over like day-long video, like we discussed before, there may be some very large amount of like knowledge, and there may be some duplicated or conflicting knowledge. And we target to build evolving compressed and up-to-date semantic memory for this case. Specifically for each step, like every 10 minutes, for example, in this example, we search for semantically relevant memories and do like deletion or merge of past events compared to like new incoming memory, and also updating them with new semantics. For example, here in the like red text, Lucia tend to like sweet desserts in the past in the existing semantic memory, but when the new like memory says Lucia dislikes overly sweet food, then these two like semantic memory like conflicts. So updated semantic memory cannot store either like Lucia like or dislikes, so it deletes. And for example, like blue one, I often eat fruits and snacks. They can be merged to like compress the total amount of semantic memory as we are like dealing with like a day long or even beyond. So this really helps like encoding long-term memory, but like compressed in mode. And over these like two textual memories, as introduced earlier, visual memory is one of our key memory in this work, which captures rich visual details that cannot be fully conveyed through text by storing selected frames. Here we support like two scenarios, and one is keyword-based search that encodes segments for every fixed intervals into visual features via multimodal encoder. And another one is timestamp-based search. And this retrieves a clip for the specified time range when required. For example, if the retrieved textual knowledge in the yellow box is from date 5, like 5 p.m. with like she combines several ingredients, then and next we like require the visual details of what several details Alice used to make cookies. Then rather than search with the query for the use the keyword-based search with the query Alice combining the ingredients with multimodal encoder and like doing similarity search, it is much more effective to retrieve visual frames from the given timestamp, like day 5, 5 p.m. And to support both, we index and store frames at visual memory in two different complementary modes. And these three memories discussed completes our like full multimodal memory. And now based on these multimodal memory constructed, spanning both textual and visual modalities, WorldMM has a retrieval agent that iteratively decides which memory to access and what query to issue, conditioned on the user question and the retrieval history. This is very required as we have three different complementary memories and each query has different needs, and maybe the like with the first attempt, they may not collect like sufficient content to answer the question. So we adopt the adaptive memory retrieval process. For example, like after taking a look at episodic memory about lunch with Alice and this example here, since the query asks for what do we usually have for lunch, it calls like semantic memory. However, the semantic memory may not include which exact food among Thai food they usually have. So visual memory should be utilized at next like iteration. And with these like all collected evidence from all iterations, response agent makes the final response. With the examples shows, with these examples, they show like very sequential search over different memories, but in fact, there are also cases where episodic memory is called with different memory even after like calling episodic memory. So episodic memory can be called as much as you want if like we have some missing pieces. So this adaptive memory retrieval really helps like from retrieving from the multimodal memory we constructed earlier. And these completes our WorldMM architecture.
Yeah, thanks, Woongyeong. And hello, everyone. My name is Kangsan Kim, and now I'm going to present you about the results and analysis of WorldMM model. So let's start with the main results on the table one. So we evaluate our WorldMM models and several different kind of baselines, including the zero-shot models, long video understanding model, ROC-based, and memory-based video LLMs. So as you can see, our WorldMM GPT-based one achieves the best score compared to the other baselines, which achieves the average score of 69%, which exceeds the strongest baseline by like 8%. So yeah, it shows the superiority of our method compared to the other baselines. And if you see the second group, which is long video LLMs, they actually shows the worst performance, and it shows that if the video got much longer, like over like days long, then putting all the information to the video LLM actually make make them worse to perform the video understanding because they're distracted from unrelated segments or informations. But if you see the ROC-based and memory-based video LLMs, including our WorldMM, then it actually shows the better results compared to the base models and long video LLMs. So it shows that selective retrieval works actually is really important to understanding long video or like days long video understanding. And compared to the ROC-based and memory-based method, which usually uh, leverage a single modality of information or like a fixed duration of retrieval when they retrieve the relevant clips. Uh, Actually, our WorldMM model can actually integrate texture and visual memory together, and also they can do the adaptively select temporal scopes based on the given query. So they show the best results because of those kind of dynamic search and multimodality. And also on the right side, right bottom figure, we actually plot the memory type utilization of WorldMM on 5 distinct categories in EgoLife QA. So uh, if you can, as you can see, most of the queries are relied on the episodic memory usually, but if you see the habit insight or relation map, because these kind of queries demand some relational information or long-term information, so they slightly more tends to call the semantic memories. But if you see the event recall or like entity log, they usually require some object understanding, object detection, or like action understanding ability. So they prefer to call the visual memory like compared to the other categories here. Next, please. And we shows the effect of each memories in WorldMM. So as you can see in the table on the top, there are some variants that use episodic only, visual only, and episodic plus semantic memory, and episodic plus visual memory, and our WorldMM model, which use all the episodic, semantic, and visual memory. So when the model leverages all the 3 different kind of memories, it shows the best performance, as you can see. So it means that different kind of memory should provide or contribute the different kind of knowledge to the model. And let's go deeper on in each type of memory. So if you compare the performance with the red boxes, then on the entity log categories, rather than just use the episodic memory only, when the model use episodic memory and also the visual memory together, then it shows the better results. And on the right bottom figure, it shows the why. It shows the reason why the model should leverage the visual memory together. Because in this case study, so the query was about what did we bake in the oven last time. But in the turn number one, it called episodic memory, but it failed to provide any information about the object. But if you can see in the turn two, visual memory can provide some visual informations, so the model can notice that it was the sweet potato in the oven. And in the table back, if you compare the scores highlighted with the orange boxes, then for the habit insight categories questions, when the model used semantic memories along with the episodic memory together, then it shows the better results rather than just using solely episodic memory in the inference. So, and on the right bottom case study, it shows why the model should call the semantic memory. So when the query was about what do I habitually use to wipe after washing kitchenware, then uh, in the turn number one, episodic memory couldn't provide any long-term information or habitual knowledge, but as you can see in the turn number two, it can provide a semantic memory can provide some long-term or relational reasoning information to the model, so model can get the correct answer to the user query with the semantic memories. And we did some additional analysis about our WorldMM. So in table 3 on the left, we measured the average TIO scores between the gold segments and the retrieve segments of each method. And because WorldMM can do the adaptive memory retrieval, so it shows the best TIO scores compared to the other baselines. And in the middle, in table 4, we actually did the ablation studies in terms of the components of each component of WorldMM. And if you compare the fixed timescale performance with WorldMM, then it shows the biggest gap, biggest performance degradations compared to the WorldMM. So we find that the retriever with dynamic temporal ranges actually has the strongest impact on overall accuracy of WorldMM. So lastly, on the right side, figure 7, we plot the accuracy of WorldMM with different maximum possible retrieval steps. And because model can leverage more information as they call the memories more, so it means that like increasing the maximum retrieval iteration consistently improves the accuracy across the all benchmarks we tried. And lastly, we would like to highlight the efficiency of WorldMM because WorldMM can just retrieve only the informant or like relevant video segments, so it can get the best IOU of compared to the other baselines in the figure 5, and it leads to the leads to the best average accuracy performance in figure 5 and also in figure 6 because it actually retrieved not too long, not too short, the exact duration of the segments to answer the queries. So it shows our WorldMM model shows the best position of in the latency and accuracy trade-off, as you can see in the figure 6. Yeah, to sum up, so these are our takeaway of WorldMM. So WorldMM is a multimodal memory agent designed for long video understanding and reasoning. So we use 3 different types of memory, which is episodic, semantic, and visual, to preserve events, meanings, and visual details over time. And lastly, leveraging both visual and textual information, and retrieving only relevant clips with dynamic temporal scales adaptively are crucial in long video understanding. And to finish, before we finish the presentation, we would like to quickly introduce our ongoing work. Even though it's not multimodal, but we're currently focusing on how to leverage memories effectively in self-evolving agents. So, and specifically, we're studying about the transferring memories from previous tasks to new types of text. So if the self-evolving agents generate the two different memories, which are task-specific private memory and task-agnostic shared memory. So, and then it can also actually transfer or leverage the shared memory to the other new tasks. For example, like software engineering task to the ML engineering task. Then we can improve the performance of self-evolving agents in different kind of tasks, even though it was new to the model. Yeah, so this is the end of our presentation, and thank you for listening. And we would like to discuss our research further with you guys. So if you have any, if you'd like to discuss this research with us, then please email us. And if you have any questions, please feel free to ask your questions. Thank you so much.
Awesome. Yeah, thanks, Kangsan and Woongyeong for preparing very in-depth detailed slide and the materials for the session. I think due to time constraint with the webinar, any question, let's do it async. So the attendees, if you have any question about WorldMM, feel free to put on the Zoom chat so that the researchers can provide a concrete answers for them. I think at the high level, like really enjoy the way you break down memories into like three separate types, right? As you mentioned, episodic, semantic, and visual, and then like during the framework, you kind of dynamically like that adaptive memory retrieval, you can adaptively choose the right memory classes, right, in order to like return the answer that is most adaptive based on the query. So it's a very like intelligent and dynamic way of like tackling this multimodal agent problem. And I think like internally we are also trying to do something kind of similar on this respect. So yeah, I started to like learn from kind of job design and enable like the long-term understanding of the agent in context of long-form understanding. Yep.
Yep. Thank you.
Yeah. All right. So with that, I will pass the mic to Prashant to want to get started. Also, like Kangsan, if you can start sharing your screen so that Prashant can. Yep.
Perfect. Thanks, James. Give me 1 second. Can you see my screen?
Yes, we can see it.
Great. Hey, everyone. Thank you for joining. My name is Prashant Trivedy, and I'm the founder of GameCut AI. James did mention at the start, I am based in New Zealand, so I apologize if my voice sounds a little bit groggy. It's 7 a.m. on a Saturday here, and I have a newborn in the house as well. So today we're going to have a quick chat about how GameCut can help go from footage to highlights in minutes and not hours. Quick structure of this presentation. One, we'll cover some of the challenges with sports highlight generation. I'm not too sure what the audience in the room is like, but if people are not familiar with what it takes to go into generating sports highlights, hopefully this will be a bit interesting and insightful for you. We'll then cover how GameCut helps, specifically some of the capabilities we offer to help solve some of these challenges. And then we'll have a quick dive into how it works with a overview of the TwelveLabs integration. And lastly, I know many of you would just like to see it in action, so we'll also take a quick look at the demo. Now, some of the challenges with sports highlights generation. off the bat, it's a massive time sink. So on average, it takes about 8 to 12 staff hours. So staff hours is human hours. If it's one person doing the editing, it would take 12 hours. If it's two people, it may take 6 hours each. To generate one highlights video for a single game. So if you think of a football game, which might go on for 90 minutes, this is 8 to 12 hours of editing time to generate a highlights reel for that game. What that means is organizations are struggling to put out content fast enough. A study by Deloitte recently found that 90% of Gen Z and millennials are consuming their sports content on social media. So they're not necessarily watching the entire live game, but what they are looking for is a way to be part of the action and be engaged through consuming video on social media. Now, the long editing time and the high cost and time involved with that means some sports organizations around the world are struggling to actually meet that demand. This is where GameCut hopes to come in, and we help sports organizations analyze, clip, and share highlights reels in minutes. So ultimately looking to take that 12-hour time frame down to minutes. Now, again, GameCut isn't looking to replace your full broadcast production 15-minute highlights reel, but especially in social media where users and fans are looking for these quick snippets of compilations to get them through the day and catch up on what games were played. That's our, I guess, our niche and our sweet spot. Ultimately, how GameCut can help is by increasing the engagement of fans. There is this upside of increased revenue. More fans equals potentially more ticket sales, more merchandise sales, and even using GameCut, being able to demonstrate a return on investment to sponsors is what ultimately can help bring in additional sponsorship dollars. And on the other side, we're looking to help organizations reduce their costs. How can we minimize the amount of time and human effort spent to generate some of these highlights reels so that they can then meet the demand from their fans? How does GameCut work? Very simple. First, upload any practice, game, or behind-the-scenes footage. If we think of many organizations in the world now, they're looking to show more behind-the-scenes vlog-type content to their fans. Secondly, users can then search and analyze the footage, again, powered by GameCut. This allows natural language search, either for specific events, but hopefully what you'll see with our GameCut agent is actually just describing the type of highlight video you want and actually getting a fully edited, clipped highlight reel in the output. And once that's generated, of course, that's available for you to share to any social media channels or any platforms you choose to. One of the important things I think to touch on is that putting out content, especially for teams, leagues, and sports organizations, is to ensure that the content is consistent and on brand. To help with this, we'll take a look at brand templates, which is a way organizations can pre-configure custom intros, outros, music, and overlays so that whatever content you're putting out does meet the look and feel that you want and you want to be shown to your fans. Now, a very quick overview of our TwelveLabs integration. So some of the capabilities within our product, so using semantic search or AI agent, in the multimodal search, so searching through video, transcription, etc., is powered by TwelveLabs. The way our integration uses the TwelveLabs Node.js client in the back end, which is ultimately interacting with the relevant APIs from TwelveLabs. We are using the latest Marengo 3 and Pegasus 1.2 models to power the multimodal search and some of the analysis features that we offer. We're also benefiting from the webhooks TwelveLabs offers. Of course, longer videos do take a little bit more time to index, so we rely on the webhooks to inform us once that indexing or that analysis process is complete on a video. So let's jump into a quick demo. Some of the things we'll take a look at, and if we put our hat on of maybe a club manager or a social media person within a club who wants to put out additional content from the footage that they have. So we'll take a look at the simple upload flow. We'll have a look at our project-based workflow, which allows users to search across multiple videos or multiple files without needing to, specifically focus on one and then have linear time spent on each additional video they want to analyze or search. We'll have a look at some examples of the natural language search and analysis. Now, when we talked about the challenges with traditional video editing for highlights, it's essentially a human watching the entire match end to end and tagging it with the events that occurred. So, for example, player A scored a goal, player B passed to player C. We'll look at how our search and analysis essentially looks to minimize or potentially eliminate that process. Then we'll actually generate some highlights. One, using the manual process where someone wants to have a little bit more control over what clips are selected, how the ordering of the clips, etc., are arranged. But we'll also look at our GameCut agent, which is a completely hands-off way, so a one-click way to generate some highlights reels, again, in seconds, potentially minutes. We'll also touch on the brand templates. As we mentioned, having that visibility, consistency, and compliance is really important for the larger sports organizations, making sure they have a consistent look on their social media channels. So we'll take a look at how that's achievable. And then lastly, we'll look at sharing these video clips externally. So what we're taking a look at here is the GameCut dashboard. So any content creators within teams, leagues, schools, athletic departments, this is where you would come to upload your footage and then generate your highlights. Now, our system is designed around a project-based workflow. And what that means is a project could represent, for example, for a league, an entire tournament. For a team, it could represent all the footage for their season or all their archived footage historically. However you choose to represent a project for your use case. Ultimately, what it allows is search, analysis, and editing across multiple video files. So this is a collection of video files that we can do some interesting things with. Now here we have some footage from a couple of English Premier League games. Now let's jump into what we can do from here. If we jump into the search tab, a very simple example is I would love to see all the goals that were scored in this tournament. Now we've done a very simple and crude search for goals. We can see that the video, the multimodal search, is actually returning us clips of the goals that were scored across these video files. Now, if we think of this from an editing perspective, finding this would traditionally have taken a real human potentially 90 minutes to scrub through, 90 minutes per game to scrub through to find each goal. Now, this has given it to us in seconds. Now, as an editor, I can find the clips I like. And if we're talking about that, being in a little bit more control of what's outputted, I can add these to the reels that I'd like to generate. Now, that was one example of the search, which is just a generic goals search. We know, so I work in this team or I work in this tournament, I know that Declan Rice, who's one of the players, actually scored a goal. And I'd love to include his goal in this highlights reel. So let's take a look at how the search can actually be more powerful to find a goal scored by a particular player. Now, this is Declan Rice, and this is the goal he scored. So now we know, fantastic, let's add that to the reel we'd like to generate. Now, again, with our commercial hat on, we also know that our sponsors are paying us a lot of money to hopefully get their brands out there. So is there a way we can get maybe some sponsor billboards in the background of our footage? Now, Bitway is a sponsor that has some footage here. So let's try searching for that. And great, we've got a fantastic billboard of Bitway in the background. Maybe we should add this to our reel to satisfy our sponsors and hopefully lock in some additional funding for the next year. Now, the clips we've selected can all be, we can see here in our draft highlights reel, all of the clips have been put together. What we're also seeing is we have the ability to manually pick an intro and an outro. And this is where we talked about the custom branding and that branded consistency approach. Through our brand templates, you can set up your own custom intros, outros, and even licensed music so that each highlights reel that's generated stays compliant with your policies. Now here, let's just stick to our fictional San Francisco Seals team intro. And we've also got some music that we'd like to use in that highlights reel. I had a few clips that I'd already added to the highlights, but let's generate that. Now this kicks off a job on our end. We go through picking up the reels, doing a little bit of additional refining on them, clipping them together, and then hopefully giving you some nice output. Now, while that's happening, I think it makes sense to take a look at the more hands-off approach and the faster AI-powered or AI agentic approach to generating these highlights reels. Now, if I go back into our project, we can see this interesting AI highlights button here. Now, what this does is we can abstract away all the work we just did. Here, I can simply describe the type of highlights reel I'd like and let the AI agent go to work to generate this. So for example, we'll do something different here. Maybe we'll do it from the perspective of a coach. And we know one of the areas we've been working on is our corner kicks. And we'd love to review our corner footage so that we can see, hey, why were we not able to convert these into goals? Now let's say create a 1 minute reel of all corner kicks. Let's stick to that. Let's keep it very simple. Now, again, if we wanted this to be external facing, we can choose a brand template, which again would apply the relevant intros, outros, and music to that reel. Our agent is now kicked off. It's doing a few different things, finding relevant clips, analyzing the actual clips, including the transcripts and the audio from those clips. And then we said we wanted it to be 1 minute. Our agent's going through and finding the best ones that can fit within that 1 minute time frame. Once that's done, similar process applies. It goes off and starts generating those reels on our end. Now let's see maybe how these were working. So we can see here 2 minutes ago, we just generated highlights reel. And this is the one we generated manually. So we explicitly searched for clips, added them to our highlights reel, and then generated them. Let's take a look at what this looks like. you may not be able to hear the audio because that's coming through my headphones, but we'll get a good idea anyway.
You can also like share audio via Zoom if you want the audio to come through.
Let's try that out. James, would you be able to walk me through that?
Yeah. So just stop sharing for a second. No,
Sharing.
now you do click share again, and you should see this says
Understood.
style
Got it.
on the right
Yeah,
side.
sorry. I haven't used Zoom in a little while, but here we go.
Oh, you muted, Prashant. You need to unmute.
I think sharing audio seemed to have muted me. Hopefully we're back.
Yep.
Perfect. We won't watch the whole thing, but hopefully that gives you a bit of a glimpse into how the system works, how someone can go in with a little bit of a more hands-on approach, find the specific clips they're looking for. Again, this may be for social media content. If we think of a coaching use case, finding player-specific content to help in additional coaching and training sessions, etc. We can also see that the agentic job that was kicked off is also complete. So that would have gone out, found the relevant clips and stitched them together. Just having a quick look at how the brand templates work. We saw in the video we generated, it was a lovely video for the San Francisco Seals. Now, obviously, any team organization out there, they can come into GameCut and configure their own templates. Again, with their own intro, outros, music, etc. For any marketing agencies or content agencies, there is the ability to create multiple templates and then apply the relevant one for the content you're creating. Now, jumping back into our presentation, hopefully what you all saw is end-to-end from going from uploading footage, using the project-based workflow to search, analyze, and then edit reels across multiple videos and files. We also took a look at the natural language search and analysis. So no human had to go through and tag these video clips. The AI, again, powered by TwelveLabs, was able to understand the footage based on the context that a goal was scored, based on actual transcription, audio, and contextual analysis of knowing Declan Rice scored a goal, but also understanding text, the text that was visible on screen when we search for Betway, and we can find sponsor content within the video to include in our highlights. We took a look at generating highlights, both the slightly more hands-on approach, as well as using the GameCut agent for essentially the one-click generation. We also looked at the brand templates, so brands and organizations can have maintain their visibility, their consistency, and compliance and their internal policies. And lastly, we didn't actually take a look at sharing, but as a coach or a organization, if I wanted to share some of these videos, one, I can download them directly from the platform, or I can share them. One of the things we are looking at doing, depending on our coaching use case uptake, is being able to create private shared pages for a team or a player basis. So if you're thinking of training footage, etc., compilations on a per player or per team basis, we can hopefully allow you to privately share that to your players. Now, who do we help? Of course, off the bat, teams who are looking to generate highlights from their games maybe use the tool to do player performance reviews and ultimately increase fan engagement from the content they're putting out. We're also looking at talking to leagues and tournaments who are looking at churning out high volume content. Again, 90% of Gen Z and millennials are looking at engaging with sports content on social media. GameCut aims to be that tool that can facilitate and allow this to be possible. Again, with that Betway search, we also saw how it could be used for sponsor ROI analysis and demonstration to sponsors that, hey, we have this is the type of visibility you're getting by sponsoring us. We're also looking at talking to schools and universities, as well as coaches, to see how the tool could help with player-specific highlights and recruitment support. We know a lot of time is spent on generating player compilations to then send off to colleges for applications. And again, that coaching use case for game day review, practice planning, and again, additional recruitment support for your athletes. What's next? Currently, we're in closed beta. We're in use with a couple of teams and leagues in New Zealand, getting some of their feedback. We'll be working on refining the product over the coming weeks. We do have a product hunt launch on January 19th. The URL is there, producthunt.com/products/GameCut.ai. We'd love any follows, upvotes, or comments on the day. Feel free to put it in your calendar. And then, yes, looking to do a public launch. I guess the explicit call out here is if you are someone that works within a team, league, athletics department at a school or college, we'd love to talk to you to see whether GameCut can fit into your workflows and hopefully reduce that time, either unlock these use cases that you previously weren't able to do due to the high cost and time associated with it, or to facilitate and speed that up for you. Now, if you are interested in what we're doing, feel free to follow us at GameCut.ai. You can always reach out to me at Prashant@GameCut.ai to learn more. And we'd love to chat to see if we can help. Happy to pause here and take any questions. And James, anything from you as well?
Awesome. Yeah. Thank you, Prashant. Very, very nice demo of the application. And I think a lot of the capabilities that you mentioned, from brand sponsorship and player detection to compliance, right? And quick fan engagement, those are very relevant use cases that we have seen from a lot of our major media and sport customers. So I'm glad that you kind of showcase all that later out here during the webinar session, so that people can have a visual appreciation, right, for the kind of like workflow capabilities and advanced features that sort of user persona, right, can benefit from using application beyond top of TwelveLabs. I know we're kind of running out of time a little bit, but let's spend the next maybe for folks who have to go, feel free to jump. But there's actually a good amount of question on the Zoom chat here. So yeah, Prashant, why don't you just go over all the messages on the Zoom chat and then kind of answer them chronologically.
Sure.
Yep.
Let me get these here. But yes, James, touching on one thing you said is absolutely right. There are sophisticated editing teams and broadcast organizations out there that are more than happy and have the capability to do a lot of this editing themselves. There is a long tail of organizations, teams, colleges that would love to do this but don't have the tools to do it. And that's essentially the gap we're looking to fill.
Yep.
We have MCP for GameCut. Not at the moment. If we get a lot of demand for that, that's definitely something we we look at offering. How do you ingest video content? Currently, it is an upload process. We are looking at integrations with asset management, digital asset management tools, etc., to ingest that content automatically. We're also looking at potentially building some plugins for editing software like Premiere Pro, so that a lot of this editing, upload and ingestion process can be automated at least. From list of video upload to search videos, what is the latency? I don't have a specific latency number off the top of my head, but from hopefully what you saw in the demo, it's very responsive. It's near instant from searching to providing some of the search results. Hopefully you saw that the search is near instant. Where we take a little bit of time is the actual stitching it all together and generating that output file, because that takes a little bit more computational power. Does your system require consistent uniforms with jersey numbers, player names, etc.? Ben, great question. And perhaps James can also jump in here on the TwelveLabs side. Having consistent, the search is essentially it's multimodal. So it's using what it sees. There is an option which we are looking at implementing in the future to do image-based search. So if you had player images, faces, etc., we could potentially increase the accuracy of the search using that. But it's also using things like the commentary, the transcription of the video, as well as what it's visually seeing. So if it's seeing rice at the back of the jersey clearly, that is also what it's using. So currently it's using context that it sees and hears visually. We are looking at adding in some additional features, again, utilizing some of the capabilities TwelveLabs is rolling out to provide a more robust search using, for example, theme images, player images, etc. Matt, does GameCut add transitions? Yes, we do have transitions that GameCut can add in between the clips. That can be configured either in the editor. We are looking to add that to the brand templates, so a brand can have a very consistent output for the highlights they're generating. Have you considered how integrating to LeagueStat APIs could further enhance results by providing an additional statistically based mode for search of videos for highlights and assembly? Eric, that is a fantastic question, and yes is the answer. The challenge we've been finding is finding the data feeds for certain types of sports. I'm a cricket fan, and as a cricket fan, there is a ton of data available. Getting access to that through the API is a little bit tricky. Services like Cricinfo that offer a ball-by-ball analysis of what happened in the game. Yes, if we could marry the two up, that is absolutely something we'd love to do. It's a little easier for some sports than others. Any plans to support automated stats tracking based on video footage in addition to highlights reel? Then yes. Again, like we're currently in closed beta, and a lot of exactly what you mentioned is some of the feedback we've been hearing as well. So we are looking at additional data inputs that can help either with the output generation or the analysis that we can provide. And conscious of time as well. And are companies like Huddle and Flow Sports current users of GameCut, I assume? The answer is no, but we'd love them to be. So if you know anyone in Huddle or Flow Sports, feel free to refer us.
My current mandate, I'm sorry, I'm a little laryngitic today, but my current mandate or my kind of white whale is actually specific NHL teams. I was on a call yesterday with TwelveLabs, and the ask that I have gotten from two different teams is being able to identify players without facial recognition and without jersey numbers, which is a really tall ask. So 12Labs is, I'm sure, banding about other ways to identify players just by size, shape, gait, and whatever that may be. But that is definitely something that I'm being asked. And so, I mean, but this is great technology just from a pure production standpoint. I think it's cool. So, but yeah, I know a guy at Flow Sports I can call.
Hannah, feel free to flick me an email or add me
You
on
bet.
LinkedIn, and happy to continue chatting.
You bet.
Perfect. You break video into frames and then do frame understanding. Yeah, so Suvasish, a lot of the analysis, indexing, and video understanding is powered by TwelveLabs. They do have their own proprietary models, which I'm sure James can help talk through. But yes, they are looking at the video to understand what's going on rather than simply either listening to the commentary as an example. James?
Yep. And like we have a lot of content on this as well. And I think even from the first presentation, right, from the WorldMM team, right, they did mention a couple of slides about the limitation of frame by frame processing. So like we have to, that's not like the way we want to tackle this problem. Unlike other frontier model like Gemini or GPT-4. So like what we do is we turn video into vector embeddings, right? That holistically represent different objects, activities, concept inside the video itself. And it's not at the frame level. We basically have like proprietary scene detection algorithm to like detect when there's a scene change in the video, right? And for every scene change, that will become like a token input to the video models, right? And then we got like the video, like the scene level embeddings for that specific scene, right? So that specific scene can be 10 seconds, can be 20 seconds, can be 30 seconds, right? So multiple frames all together, right? To capture information from that scene. And this is like superior compared to the frame approach because there are like temporal activities happening throughout those sequence, right? Like player passing the ball, scoring a goal, moving up and down, moving left and right? So like these are like action in space and time that need to be captured with like that sort of temporal understanding, and that cannot be captured using the frame approach because static frame cannot tell you whether that is like going left or right or up and down. It's just like a sequence of footage. So yeah, that's kind of like a very simple breakdown on how we think about like scene level understanding. And I think there's Eric kept the final question. Prashant, if you want to quickly answer that, and then we can probably close out the webinar.
Yep. Eric, yes, we are currently in the process of implementing the entity feature, which would again unlock that additional search capability using images, etc. So looking to beef up the search capabilities, looking to ingest additional data to also complement that. And then, of course, on the content and the video output side, yes, we support some of the things out of the box right now, transitions, custom intros, outros, music, etc. Looking at making that a little bit more sophisticated and robust.
Awesome. All right, thanks, Prashant, for answering all the question. And it looks like there's a lot of like interest on the design of how you build it, as well as like the expansion of the product. And from a TwelveLabs side, we would love to collaborate with you more as you think about launching it and like get more adoption of the end users. Yeah. Also, again, thanks Kangsan and Woongyeong for the first half of the webinars for looking at the research perspective and outline some of the fundamental like AI the research challenges that I have to deal when building, video agents, which is what I would say like kind of the next phase of our company as well. So so as you can see, like we have both like valuable insights from kind of the commercial and product side, but also like from the kind of in-house technical AI research point of view. So I think our goal is just to like try to build the best API, the best model, and then offerings that support both developers and researchers to take advantage of the exciting world of video understanding. The recording of this webinar session should be available on YouTube probably like by early next week. So I'll be sure to share that with the speakers, so you can share that again in your social media. Once again, we run this session on a weekly basis every Friday, pretty much. So if you find this to be informative and insightful, we'd love to have you rejoin our session next week. With that, thanks everyone, and hope you enjoy the rest of your Friday as well as your weekend. Cheers.
Thanks, everyone. Bye.
Thank you for the invitation.